Alex, how can, because I have to leave to keep out this. Okay, so I have one presentation to upload there. Sorry. No, no, it's okay. No, plus. Underscore is this one?
Underline?
No,
What do you want?
just a minus here.
No?
No?
Maybe here?
Oh, it's okay.
No?
No,
Sí?
no.
Ah, no, it's underline.
Tac. Okay, it's fine. We succeed.
Vale, you can copy into the...
Okay, then tac and then.
Okay, here. Perfect.
Okay. Okay, so I could out from this. Delete. Yes, and we can switch this. Okay. Yes, yes.
All right, dear colleagues, thanks a lot for being here, and thanks a lot also for being eager to learn about INSPIRE. There is lunch served outside, and we are all here, so I hope that you leave the room happy after the 1-hour session and that we're going to provide for you. What we're going to do today is continue the work, the training from yesterday. Just for our information, how many of you did attend yesterday? Were you here? Not all of you, so we're going to repeat 1 or 2 slides from yesterday to just introduce the topic and then continue with the network services. Something that was mentioned by our colleague Vlado Cetul during the training yesterday, but we're going to elaborate into further detail today. So this is the first part of the training. Secondly, for those of you, and I'm sure that's the majority, if not all of you, who would like to learn even more, Giorgio Saio will be presenting the results of a project called Linkvit and a platform, online educational platform, where you can dive into additional details if interested. We have to start, we have to finish at 1:30 because there is another plenary, so please, apologies for the quite substantial amount of information that you're going to hear. All right, recap from yesterday. INSPIRE provides a pan-European spatial data infrastructure perspective on geospatial data with the ultimate goal to unlock. So it creates the conditions on a legal level, also the technical conditions for unlocking access to geospatial information across Europe. And allow me to just remind something that I think was mentioned yesterday, but there are certain principles that INSPIRE endorses and strongly supports. First of all, that data should be collected only once. Why? if we assume that there's a quite heterogeneous, diverse, and large number of data providers, it might be the case that those data providers have some sort of duplication of the data that they are collecting, maintaining, and broadcasting, which, if we look at it from the perspective of the taxpayer, who is ultimately paying the bill for all of those exercises, that's not a good practice, right? So INSPIRE says data should only be collected once. Who should be collecting the data is, of course, not specified on a legal level, but INSPIRE is an opportunity, is an occasion for the data providers on a national level to sit together. It triggers a discussion so that they can discuss among themselves who should collect what. There are very good examples in individual member states on this being then triggered by INSPIRE. I immediately can think of the Netherlands. They did some national pieces of legislation where they basically subdivided. This institution collects water, this one collects addresses, and so on. Then it's not only this, but INSPIRE also defines on a conceptual level that it should be possible to combine data from different sources. So this is the benefit of a spatial data infrastructure. So reuse of the information and use, but in a cross-border use case, cross-domain, so it might be between individual domains, or combination of both. So it might be a cross-border, cross-domain use case. So this is where the benefit of a nice spatial data infrastructure and the horizontal role of data becomes evident. Again, focus on reusability. The idea is that providers should ensure access to the information. Then it is up to the users to use, to reuse, and to make the most out of the data. INSPIRE, as such, does not does not require anything on the application level. So this is there is data that is unlocked, that is being exposed, that is accessible, so that it can be further used and reused. And it should also, geographical information should be easily discoverable together with its metadata. Metadata, we will elaborate a little bit more on that later on, but this is crucially important because, you know, who could create it, when was it created, what are the access constraints, who is the contact person is essential so that users can make the most out of the available the data. Last but not least, distributed service-oriented architecture. So the idea is that the geospatial data sets are being made available through web services in a distributed manner, where they would be best managed. Now, this is not defined because there is no straightforward answer to the question, where is a particular data set best managed? Might be a regional level, might be on a national level. There might be a European institution that is distributing data sets on behalf of the member states. So there are very, very different ways of doing, but we're best managed to ensure that there is efficiency gain out of exposing the data somewhere. Usually, when you hear we're best managed, think of it as, in the majority of cases, that would be on a provider level. Why on a provider level? Because providers know best their data sets. They have usually another interest, so they don't do it only for the sake of complying to INSPIRE legislation. They have a certain mandate to protect the environment, to collect in accordance with national legislation usually. So service-oriented architecture, think of it as individual services that expose. And there is no over-centralization, so there is no some mega system that is collecting everything, but everything is exposed here and there. And if the services are running properly, then one can combine in a near real-time information, mesh it up with other sources, download, create bigger data sets, and basically play with the information. So, thematic scope, this was covered, I think, 34 themes subdivided into 3 annexes that actually are horizontal. I don't know what is causing this. Sounds like an airport or some train arriving near here. But Yeah, basically think of those different data teams not as different 34 silos, but on a data modeling level, there are linkages inside. Those linkages enable us to ensure that we can use really in a cross-border, in a cross-domain setting. This you have seen, I think, those of you who attended yesterday, but we need to mention a few things on it with a little bit more focus on the network services. So this is the overall picture of the INSPIRE architecture. You see that the bottom here, this is the actual data plus the metadata. And the individual storages plus two types of metadata. Metadata about the individual data sets, plus metadata about the services. So this is, we have to describe both data sets and services. And then there is this service layer that sits on top of the data. We distinguish in INSPIRE on a legal level several types of services. I'm going to elaborate on each of them a little bit later. And as you see, here is the application layer on top of this. The top is the application layer, where there is no actual legal obligation. It is up to anyone to build whatever nice and fancy applications on top of the data. Now, if we look at this architecture, the left part has got to do more with national obligations. This is the data from the providers being unlocked, being harmonized, being exposed through the services. The right one is more the spatial data services, and the registers, for instance, are pan-European services. So in terms of deadlines, you cannot imagine that such an initiative with such a level of complexity can be implemented overnight. Of course, it's a process. I always see it from a process point of view. So all of this has to be achieved by 2020. If you look at the deadlines, they start from the services, so there should be the individual services being put in place, and then gradually it goes towards the more complex tasks being related to harmonizing the actual data sets. Hopefully by 2020 we will have the whole pan-European data infrastructure being implemented. Then something else that I think was probably mentioned yesterday, the directive itself, into force since 2007, is a framework directive, which is a relatively short piece of legislation which provides the overall frame, and then there are a lot of legally binding, called in INSPIRE language, implementing rules. And then there is also a lot of guidance that is non-legally binding. So it just tells how this or that component may be put into practice, may be implemented. But if someone wants to do something differently, that's absolutely fine. If the legally binding, which is on top of the slide, is being fulfilled. So regarding the network services, there is a whole bunch of technical guidance documentation, and there is an implementing rule, this one 1089, the last amendment from 2010, which is dealing with defining on a legal level what should be done. And in response to this legal individual technical guidance for metadata, for the different types of services. I skip a little bit to save some time. So what are those types of network services in INSPIRE? So they have to do with the discovery, the view, download, and transformation of geospatial data. So if we look at discovery services in particular, those discovery services, as the name implies, have to do with metadata. So as was mentioned, the metadata is very, very important, but it is not only needed to create metadata for each of the data sets. This metadata needs to be provided, access needs to be provided to this metadata through what is called a discovery service in INSPIRE. So when you hear discovery service, think of it, it is in general inspired by the OGC catalog service for the web interface standard, so CSW. How many of you, just for information, have know about CSW and have been using it? If you can raise your hand. So some of you. So what is CSW? CSW is a standard of the Open Geospatial Consortium, which basically provides, defines how a metadata service should look like, standardized. And there is usually, as for every OGC, in order to become a standard, there should be implementations as well. There are a lot of implementations, open source, proprietary, that can do that. On a European level, there is also a very, very really easy to use tool which can be used in order for one to create metadata. So if you go to the INSPIRE Geoportal, there is, let me just see whether we can do that. So we copy the link. Yeah, so it's not visible for some reason. It's a browser. Can we? Yes. Okay. Okay. Thank you. So it's a very easy to use graphical user interface, which is also multilingual. So these are all the official 24 languages, and then actually, when one populates all the necessary fields here, then there are some quality controls, of course. This is for the email, should contain an ad mark and so on. So then we can save the result, which creates an XML document which actually complies with what is defined on a legislative level. So it's not complete, of course. There are some other fields to be populated, but the result is INSPIRE metadata, which Thank you. You're welcome. So basically, this is the metadata record for one data set. Same thing for has to be done for the services, and then it should be served through the catalog service for the web standard. So that it can. What's the benefit of the catalog service for the web? The benefit is that this is a reusable service. So once it exposes all the metadata, and then those metadata can be plugged into the pan-European INSPIRE Geoportal. There is a pan-European, I don't know whether Vlado elaborated on that yesterday, there is a pan-European Geoportal which provides a window on the situation with data all across Europe. But as I mentioned, it's also reusable. So it can, this metadata catalog can be harvested by, for instance, there are many examples in that direction by open data portals. Technologically, it's not an issue. Open data usually uses something which is called CCAN as the front end. CCAN can very, very easily harvest CSW so that we have another perspective on the data. Or national or regional geoportals. So we again collect, there is one effort to collect all the metadata, to expose it through the catalog service for the web, and then there are many, many opportunities to reuse this. Okay, let's. In terms of each of the network services as defined in INSPIRE should comply to, should implement certain operations. So in technical terms, this means that when a service is, so it is always in INSPIRE a request-response type of architecture. So users have to send a request to the service. If the request is syntactically correct and if the service is up and running, there should be a response which is returned to the user. So it's a standard web type of request-response paradigm. So these are the operations that are mandated on a legal level for the discovery service. The first one is get discovery service metadata. So if this operation is implemented properly, when the user sends a get discovery service metadata request, the server should return information about, so it's metadata about the service. I am a service which is implemented by the Catalan government in response to this or that, and all the metadata. The next operation is discover metadata. So discover metadata is actually drilling into the actual metadata records that the service is offering. So give me information, metadata about services, or give me metadata for this particular bounding box so they can be cut by territory. And so it's an interactive way of requesting the data. Publish metadata. Publish metadata is an operation which allows, for instance, individual data providers to upload metadata to the service. So think of it as usually those discovery services, in the majority of cases, are established on a national level. So which means that the individual data providers do not have to maintain their own catalogs. It is possible. There are examples also of individual metadata on a provider level that expose the metadata, but usually it's on a national level. So if there is one service on a national level, then through the published metadata, the individual providers can actually insert their metadata records. And the last operation is called a link discovery service, which actually allows cascading functionality of the discovery services. So what does this mean in practical terms? This ensures that if there are different catalogs on the different levels, they can harvest each other, so that if we have something, for instance, for each of the regions, this is typical for countries with a federal type of governance. It can happen, German land or other examples where we have some regional and there is a national, and this link discovery service ensures that there is this cascading functionality where a centralized, for instance, harvests all the others that are for just part of the territory. So this is, in a nutshell, what the discovery service is all about. Then view services. When you hear about view services, think of the OGC web map service. So how many of you have heard of a web map service, or WMS? again, so maybe 50% of view. So a web map service is another Open Geospatial Consortium standard, which is dealing with the interactive visualization of geospatial data. So some means, again through web requests, in analogy with the Discovery service, for generating, basically, think of it as generation on the fly of georeferenced images. So what a WMS service usually does is when there is a request sent to the WMS service, it would interact with some sort of a database where the actual data are stored, generate a picture, which is georeferenced, and return it to the user. So this is basically what it does. And in INSPIRE, these are called view services, and this is extract of the directives. So view services making it possible as a minimum to display, navigate, zoom in, out, pan, or overlay viewable spatial data sets, and to display legend information and any other relevant content, again, of metadata. So the view service as such does not deal with the interface. So think of it as the technology that can be embedded in some sort of an interactive map with drop-down menus or navigation and so on. So this is basically a view service, again, based on web map service. And there are, what this slide shows, there is a wide variety of different client solutions that can then sit on top, that can consume data from the web service, starting from web browsers. The WMS allows, if we send a proper request, so syntactically correct, and if there is data that meets the criteria of our request, then we get the picture. But then it doesn't have to be a web browser. It can easily be an interactive desktop GIS type of application or a web GIS interface. So this is a very, WMS is maybe the most well-known standard of the OGC, and client support is really high. So whatever solution you can think of, starting from Google Earth, Google Maps, and Esri, all the vendors actually support it, which is unfortunately still not the case for other types of services. So this is about the view services. As I mentioned in the beginning, there are technical guidance documents for all of those types of services. So if you want to know more for the view service or discovery service, there is a guidance document for you out there, which again is not legally binding. It tells you how you may approach it. If you have another idea, that's fine, but you need to, again, there is a legally binding bit which you need to satisfy. What else about the view services? Yes, the view services also take advantage of another Open Geospatial standard, which is called the Styled Layer Descriptor. Styled layer descriptor is an XML dialect which deals with rules for visualization of spatial objects. So it's a way of describing through an XML document of how you visualize your, so what is the outline of the layer, what is the coloring of the polygon, if the polygon is, comes from a particular INSPIRE data team. So what's the idea behind the use of this styled layer descriptor, or SLD? The idea is that if we have view services in, for instance, two neighboring countries, if one country implements, another implements, and they don't follow the same portrayal rules for how to visualize the data, then if one wants to build an application on top of that, combining, then they will get a different result, right? Because one country decided to have one color pattern, the other another, so it's not really useful. Also provided that, as mentioned, the WMS will generate images, so we cannot really do anything with it. So it's not the actual data So it's the images that cannot be then manipulated. So SLD. SLD again is supported by a wide variety of individual tools, GeoServer, Degree, and so on. Operations, same as with the discovery service. There is one operation which is mandatory for getting the metadata of the service. There is another one which is getMap. So basically the user sends a request, give me this layer within this bounding box, usually. Or without, if no bounding box is provided, then the whole coverage is by default returned. And linking, again, if there is a regional view service, then they might be cascaded to the national level or vice versa. That's, we're going to skip this, we don't have time. Then we go. One more thing which is important here, there is a link immediately with the INSPIRE data specifications that Vlado talked about yesterday. There is also a naming convention for how the individual data sets should be named in the INSPIRE view service. So following, basically there is an example here following a very, very simple pattern starting with the two letters for the data team and then providing the actual layer name. Why? Again, assuming that there is a cross-border, cross-domain use case. People, it's funny how people start naming their layers. First underscore draft underscore last underscore final, or it's not a good practice. So INSPIRE mandates this as well, to have a naming convention so that, it's clear what the individual layers actually is all about. This we skip. Again, as mentioned, so there is a pan-European geoportal that provides access to a view and discovery service on a European level. This geoportal takes advantage of the view and discovery services. Download services. Now, INSPIRE also defines download services that enable copies of spatial data sets or parts of such sets to be downloaded and, where practicable, accessed directly. So again, the overall objective of this pan-European spatial data infrastructure is to unlock access. So unlocking access means also having the opportunity to download data that is public in the domain of in the public sector domain. So the directive distinguishes between two types of download services. First one is called predefined access download service, which actually deals with, think of it as the opportunity, technological capability for downloading whole data sets. And direct access which provides access to the actual spatial objects. So the first one is mandatory. Direct predefined access, so the whole data sets shall be made available through download services for reuse by whoever, basically. The second one is non-mandatory, which provides access to the actual spatial object. So this is the more interactive way of dealing with the data, right? So assume a big data set. You're not interested in the whole data set. You only want a particular bounding box, or you have a certain logical criteria. Then you send this as part of the request. Then if there is such data that meets your criteria, then you get a response with only subset of the whole data set. So it's in an interactive manner requesting on only bits and pieces. So what are the available technological solutions here in terms of different standards? It's a little bit more diverse than the other types of services. Here we have for the predefined access, we have Atom as an opportunity to implement Atom. Atom is think of RSS, so subscription type of service where the whole data set might be archived or served directly as GML. And there is a little bit of HTML code which is wrapped around the service, but this is only for the predefined access download. So the whole data set should be served like that. There is no opportunity technologically to interact with it. Okay? The other option for the predefined access is the web feature service. So web feature service can expose whole data sets again. So if there is a request can be sent for downloading the whole data set. And the work is also ongoing right now for two other standards. Sensor observation service and web coverage service to also become recognized as INSPIRE download services. So sensor observation service, as the name, it's clear that we're dealing here with spatio-temporal data. There are different domains, marine, atmospheric conditions, water, and so on, that have a lot of spatio-temporal data. In some cases, even it might be the case that there are only a few points, so the geometry is really limited, but those point locations in a meteorological network, for instance, but those points have generated terabytes of temporal data. Right? So there is a solution for such types of use cases. This is the sensor observation service. And with regards to coverages, so coverage in terms of, for instance, grids or multidimensional grids that again, some usually in the meteorological domain, again in oceanography, air pollution monitoring. There's also some, for instance, an output of an interpolation process. The web coverage service standard allows that in an interactive manner, users can, for instance, reduce by bounding box or decrease the dimensionality of the data set to just extract some piece of it. So those there are there is a process put in place for creating technical guidance for those types of services. You can find them if you go to the INSPIRE website. You will find the guidance, and they actually all of those services implement a set of operations that are again get download service metadata, get spatial data set, which is for the predefined, describe spatial data set, which is actually metadata of the actual for the actual data set, linkage that's already clear, and only for the direct access download get spatial object is the request, and describe spatial object type. So what's the type of the object that can be actually requested? Sure.
When you said that there's work ongoing, that is just about the technical guidelines, but the technical, like the format already exists, or is that?
Yes, this is only the technical guidance. There is technical guidance being elaborated on each of those types of services. Legislation stays the same. So these are the possible options of how they can be implemented. Does this answer the?
I was just asking, does it actually technically exist today? I mean, the guidelines is just formalizing, or VCS already exists?
Yes, there are implementations. Yes, I can demo maybe later if you want. There are open source proprietary technology for each of those types of services that can help implementers build. Yeah. And there are examples, there are tutorials, and I think also Giorgio will elaborate on that. There are a lot of resources that can help. It's not just an exercise where there is a technical documentation, but it can be backed up with technology as well, and with other materials to help. So, yes. Final type of service, and I will stop here because we don't really have a lot of time. Transformation service. The transformation service actually ensures that data can be transformed in accordance with the INSPIRE data models. So this is the transformation service is only needed if we are not transforming the data offline. So there is a whole bunch of tools, and this is usually the case that people transform data offline, then they serve through those types of, through the other types of data services, right? But if this is not the case, if a data provider wants to store in their native format, and there is no workflow for data transformation offline, there might be a service which should be a homegrown solution, so which is adapted to the particular infrastructure that it should be part of, to request data to be transformed in accordance with INSPIRE, right? So when after having sent the request, data is transformed, and the response is GML, geographical markup language, which will validate against the INSPIRE models. So this having been said, I hope that this was useful as content. Maybe if you have one or two questions, and then we give the floor to Giorgio to tell you how you can continue. So if there are any questions at this stage, let me know, please. We need to, I think, get the microphone, please.
Yes, hello. My name is Carsten Behring from the European Food Safety Authority. We might in the future become a user of INSPIRE data, and we are producing scientific opinions. So our the data might become input to scientific papers. And in scientific papers, there's of course the problem about long-term transparency and reproducibility of the results. That means, for example, if our scientists would use INSPIRE data, it should somehow be a way that in 20 years, reading the paper, we still can know exactly which type of data was used, and it should be somehow retrievable. Is there something in the INSPIRE standard about that, or does that need to be ensured outside of the INSPIRE standard?
Well, explicitly this is not mentioned, but implicitly, of course, those services have to be maintained. It's not only a one-off initiative where we transform, we expose something, and then we check the box, and then we turn off the server. No, they should be maintained. But the question is really a deep, and there's no straightforward answer. It's a big issue, I think, in general, because those are services. Information can be changed inside the service, which creates problems with reproducibility. There are possible technological solutions, but I don't think that INSPIRE goes in that substantial detail regarding this particular topic. So yes and no. Yes, they have to be maintained online, but I don't think that it goes into.
Because I'm completely new to INSPIRE, that every data is as well downloadable as a file, because then it could be solved. Just downloading the file, and the user need to make sure that the file is stored long term somewhere.
Yes, but is the file the same 20 years from now on?
Yeah, but we could make then sure. We would not use online services. We should only always download the data. So what my question is a bit, as I'm completely new to INSPIRE, is it foreseen that all type of data exists?
Historic data, yes, also falls within the scope, so they should be made available, yes. But in reality, pragmatically, it might be that there are some changes, because the overall objective is unlocking, and reusability in this long term is still to be. I think think of it as for those really details, it's a work in progress still. So, and see it as a process. All of you, I think it's not something that is overnight, but it's a process, and that's a very interesting question to deal with for sure. So. Thanks a lot for the attention. Giorgio will tell us about education and how to continue.
Thanks. I think that we have just 15 minutes, not more, but I will try to do in 10 minutes. I have to take the presentation outline. I don't find. Just a second. In the meantime, if you wish, there is the complete description of the package. There is some material you are free to keep after. I just can you help me just about? I don't find the.
Just get rid of this.
Yes, but I.
This one.
Okay. Because of the mouse is missing.
It's on the other screen.
Ah, okay. It's okay.
Yeah.
No, it's not this one. No? So it's... okay, I just put before in the here. Where is it? Okay. This. I don't know where, because you copied before, but I didn't know where it is. No, it was probably this one. Okay, so we found finally. Okay, first of all, thanks. I wish to thank GSC to have asking me to present the training framework LINVIT that as a GZIG association we developed in the last few years, and I will just in the context of Leonardo da Vinci project. So the project deals with digital competence as defined by the key competence for life learning of the European framework. So we addressed the vocational training in particular. Competence in geoinformation are crucial in a new European context, and we are here, and you know exactly that the competence of the geoinformation are important, and that I don't say any more about that because you are convinced, I believe. And LINVIT create such competence through a set of training modules developed in different European initiatives. So we leverage experience that come from previous project. In particular, as GZIG, we are an open association, European association grouping university enterprise with the mission of innovation and technology transfer in the field of geographic information. So we collect the knowledge and promoting European project. In such a framework, we supported the transfer of knowledge about the European GI-related directive, in particular Copernicus, INSPIRE, SACE, and Water Framework Directive, with the participation in a number of European projects like Humboldt, that developed the AIL tool, for example, data specification through the eContent Plus project, ICT, PSP for service provision, and so on. And NASIS for the SACE initiative. In parallel with that, through another European Leonardo da Vinci project, we developed the concept of a learning and a catalog of training courses, a learning metadata of courses, and then a catalog of courses, and then the possibility to have a flexible training path about that. All this schema is then applied to a number of projects like Journal City, Life Imagine, EM Plus, and so on. But altogether, we had this project that ended just beginning of this year to update and leverage all the knowledge that we got before. So we customize, we update all this package in the LINVIT training package. So we classify these modules, and you will have here the complete list with some description in different categories: context knowledge for INSPIRE, advanced technical model for INSPIRE, and then because we address some thematic community, we address a stakeholder of natural conservation and geology and civil protection. And then we define a set of modules for technology trend and innovative solution. The partners here, so that guarantee the high-level competence and the creation and validation of the training model, are the Catholic University Leuven, Danny van der Broek. So I think that you know all about that. Is also in the conference somewhere. Epsilon Italia, and his Giacomo Martirano, that is expert in data harmonization and validation toolkit. INSPIRE, that is the National Environment Agency from Italy, that is both expert in the thematic domain, for example, geological and civil protection, and but also users of this package, because it's also the national focal point for INSPIRE. Then Novogit, that is a company, but behind that there is Anders Horsman, that is one of the other expert, well-known expert in INSPIRE. Then Salzburg University, Professor Josef Strolb, for example. UAV, that make then, for the academic point of view, the validation from the academic point of view, and GSIG that coordinate all this project itself. So this is the training package, and you can see there is in the context knowledge for INSPIRE, we have introduction to INSPIRE, we have European Geoportal portals as SDI user interface, basic of INSPIRE data and service sharing, basic concept of XML and GML, basic of INSPIRE data specification, data quality, basic of INSPIRE network service, we spoke about before about network service, data harmonization concept, and then this topic has been developed in advanced technical model, where there is INSPIRE Advanced, for example, that deal with how INSPIRE could become a key enabler for government, for example. Then metadata and catalog service, INSPIRE Network Service Advanced, procedure for data and metadata harmonization with some examples, metadata and data validation for INSPIRE. Then we had some modules addressed for the specific thematic stakeholders, natural conservation and geology, for example, geological data harmonization, and then technological trend and innovative solution, introduction to linked data advanced, the introduction to sensor web. So that is the package, or LinkVic package. So right now, we discussed with GRC that a subset of this module will be considered, and is being considered and validated, to be linked to the Geoportal, and then is already the package, and then is offered to all the community. So you can both access through the LinkVic website, that you have the full package, or already started this process, we will create a subset of validated training modules that will be used through the INSPIRE Geoportal. So, and that is what is already happened. If you go the INSPIRE Geoportal, you go to the training library, and then there is already linked the introduction to INSPIRE that go to the modules that we developed in it. But this is just the starting point, and we are in the process to make that. What you see there, that you go to the training module, but also you have the metadata, abstract, structure, learning outcome, and so on. That is the metadata that we develop together with the Danny van der Broek, Josef Strolb, Anders Horsman, as a way to create a standard metadata for the modules. You can also link, sign through your LinkedIn credential, or asking for a password, and we will provide by mail. So this is the method for that. If you go to the website, you go to the training modules, you will see all the training package, and you see that there is the metadata information and access to metadata, and then the access to the module. About the metadata, you can see there is a common template, name of the module, source, how the source, for example, here was done, INSPIRE Advanced was made by Louvain, Glenn, very cool. And ownership, abstract, structure, learning outcomes, intended audience, prerequisite language, format, and expected workload, because it's a learning and then it's just expected. And then there is the assessors of that. What do you find in the modules? There is material in the different format, presentation, text lecture, audio presentation. You will listen the voice, for example, of Danny Van der Broek for INSPIRE, Introduction to INSPIRE, web lectures, video lecture exercise, and so on. Just a message for that. This package we will commonly use for making the basic knowledge for the application of INSPIRE in real life application. For example, in the EM Plus project, maybe you heard about that, it was just recently concluded, Environmental Service for Advanced Application within INSPIRE, we created the training framework of the project that we use these modules as from Linvit, so the subset of the modules we use that, and then we put some other modules specifically to the content of EM Plus. So this is, for example, and then the result of the EM Plus that is for transfer, what we make that there, for example, the Thesaurus frameworks as a service we develop in EM Plus. And then the pilot. The same for Life Imagine, we presented this morning. Integrated coastal area management application. We have the background knowledge with the modules coming from Linvit, plus some other thematic knowledge and the infrastructure, and we specifically saw of the two scenarios, application scenarios, that is soil consumption and the landslide, coastal landslide. We use as well in GeoSmart City, so we can use, and that is important because INSPIRE is not just for environment, but we use methodology of creation, the standardization, the interoperability of INSPIRE, also in the context of the government in the Smart City. And again, we have the training package of GeoSmart City, where we have the directive, then we have underground integrated management of the underground scenarios and the green energy scenarios that as a topic of this project. So we have a flexible training framework, and again, we are going to select a subset of this to be linked to the thing. One final slide that you can find also in the materials that I've distributed there. We have, as a follow-up of Linvit, we have submitted the Erasmus Plus proposal for creating an alliance between academy and enterprise, where the enterprises will give the need what they on cases, real life cases, and how the academy should prepare the academic curricula to answer to this question. And we will use the basic of Linvit as a basic for all the context of geographic information. That's all, and I hope that if any question, I am available till Friday, and you can keep the material here. Thank you very much.